All right, what I want to do now is talk about how to do bond calculations with the BAII Plus. In particular, we're going to see how to price a bond, how to find the yield rate of a bond, how to find the maturity date of a bond, and given a bond that doesn't necessarily have the face value redemption at maturity, how you find that redemption value given all other relevant information. So let's start off with an easy example of pricing a bond. So I have a 20-year $100 bond, coupon rate 3% and 4% yield rate. Find the price. So remember, unless otherwise stated, 1, coupons are semi-annual. 2, all rates are nominal semi-annual. And 3, the redemption at maturity is the face value. So nothing else is specified, so we're just assuming all that is true. And in particular, the effective 6-month coupon rate is 1.5%, and the effective 6-month yield rate is 2%. All right, and the way we're going to enter this into the calculator is we're going to treat this as if it is an annuity, which makes sense because bonds are annuities. Every 6 months, you get coupons, and at the end of 20 years, you get your redemption back. And you, of course, get coupons at the end of each 6-month period for 20 years. All right, so let's start entering this as if it's just the annuity that I specified. All right. So there's 40 periods in this annuity, 40N. The interest rate for this annuity is just the effective 6-month yield rate, which is 2%. Coupons are always F times R, no matter what. So F is 100. R is 0.015, 1.5%. So that's just $1.50 every 6 months. And what we're going to enter now is 100 FV. So you can think of that as 100 face value. The face value of this bond is $100, but you're going to enter whatever really the redemption is at maturity into FV. So it's not really face value always. But you can just remember it maybe as face value if you really want to. All right, so we do all of that. And this tells the calculator that this is the redemption at the end of 20 years. Now let's do the present value. We get minus 86 and 32 cents roughly. And that should make sense with the minus because you have to pay this amount to get $1.50 every 6 months for 20 years and $100 at the end of 20 years. Doesn't make any sense at all to get 86.32 at the beginning of this bond. Doesn't make sense to get $1.50 every 6 months for 20 years and then 100 after 20 years. That makes no sense at all. You got to pay for the bond. All right, so let's do another example where we compute a maturity date. So everything's the same except the bond is priced at 85,255. And I'm rounding that to 3 decimals so that our calculated answer is very nice and close to an integer. All right, so let's clear CBM. So what am I going to do? And I also want to check using Makeham's formula for the reason that you're going to have to find a maturity date and 4.1.4, and you're not really going to be able to enter into the calculator so simply. So it's, you're going to use Makeham's formula on that problem. All right, so we're going to enter everything as we normally would. First, we're going to enter the present value. Let me just put this up here. So 85 to 55, 255. And you have to make it negative, otherwise you'll make your calculator unhappy. We don't want to do that, and you don't want to do that, especially if you're taking exam FM. So be mindful of your minus signs. I'll actually do all this without the minus sign in a second. So this is a present value. The price of any annuity is the present value. Everything else is just like before. 2 is the annuity interest rate, just the effective 6-month yield rate. Coupons are 100 times 0.015 is $1.50. And we get 100 back at redemption. So compute N, and we get this number that is basically 45. And yeah, we would need more decimals to get closer and closer and closer to 45. But this represents a bond that matures in 45 6-month periods. And so divided by 2, that is a 22.5-year bond. All right, so let's see how to do this using Makeham's formula. All right, so I'm going to write on this, so I'm going to open up the comments section. So remember Makeham's formula. In that, really, this was K here, the way we did it. And this was also K right here. So it's actually a little easier to, instead of writing it as K, to write it like this. And then notice that we have a common F everywhere here. So what I can do is factor out the F, and then I would get present value factor to the N. But, well, I should say you factor out the F, then brackets, F is on the outside of the brackets, present value factor to the N, plus R over J, 1 minus present value factor to the N. So we're going to do exactly that here. So we have all this information from before. Again, go back to this. R is just the coupon rate as a decimal over 2, because it's given as a semi-annual nominal rate. And the yield rate, again, is just this value as a decimal over 2. So it's 0.015 and 0.02. Okay, so we just plug everything in. Again, factoring out the F, which is 100, we get the following. This here is just dump into the calculated 0.015 over 0.02, you get 0.75. And what we're going to do is we're going to set this to be X, and it just makes this problem that much more manageable. So this is also X, the same thing. So now if I simplify that, again, this is 0.75, I'm going to get 100 times brackets right there, X plus 0.75, 1 minus X. Okay? And this is largely what you're going to do in 4.1.4. All right, so now we can just distribute the 0.75. Maybe first let's divide by 100. Well, that's a 0. So if you're wondering, this is how I actually grade the quizzes and exams, though I do have a digital pen and pad that I forgot. Yeah. Okay, so we divide by 100, and, well, 0.75 times 1 is just 0.75. X minus 0.75x is 0.25x, so you just solve for x, you get 0.4102. But remember that is what x, or sorry, remember what x is. It's 1.02 to the minus n, so you take ln of both sides and solve for n. You get 44.449996. Same thing we got before. So let me just show you how to do this on the calculator. might be easier to use another calculator, as we discussed in lecture. And in particular, as we discussed in lecture, I like the TI, I think it's XS multi-view. It's basically has the same functionality as an expensive TI 8090, whatever, except no programming, no graphing, and more importantly, you're allowed to use it on the actuary exams. You're not allowed to use a calculator that has programming function or a graphing function. So, okay, so how would I do this on this calculator? You first enter the number, 0.4102, then do ln, then I would divide, parentheses, again enter the number first, 1.02, ln, parentheses, equals, and then just do the minus to make minus minus a plus, so you get the same thing. Right? Again, this is like 4.1.4, so set x to be, something similar in that problem. Okay, so let's talk about finding redemption at maturity, and this is important for 4.1.15. And we'll do examples also similar. We'll do more examples kind of like this in later in this video. But yeah. So let's find the redemption at maturity of a 20-year bond with price $90, coupons $1.50, and yield rate 2%. Okay, so here we'll actually check that this redemption at maturity is not going to be, well, I guess you don't really know if it's the face value or not, because you don't know what the coupon rate is, but that's okay. Remember, we only need, we need the face value for two things usually. Usually the face value is the redemption. Here we're saying it might not be, but otherwise all you need the face value for and the coupon rate for is to figure out coupons. Well, we have coupons here. So we're going to proceed basically like we've done before. So clear TBM. So the price we're given is 90. Order doesn't matter. So 20-year bond. I think I said 20 years. Yes, I did. Very good. The yield rate actually, sorry, it's going to be, let's make it 4%, not 2%. So yield rate is going to be what it was before. Sorry, got to change it there too. All right, sorry about that waste of time there. So the yield rate is 4%, so divide by 2. The interest rate is 2%. We're given the coupons are $1.50. So now we're going to compute the face value, and we get the redemption at maturity of $108.12. So if you forgot what the interpretation of this is, well, basically this is just the present value of this annuity here, where you get $1.50 for these 40 coupon periods, 6-month periods, and at redemption you get roughly $108.12. Present value of all this is 90. That's exactly what all this means. Okay? And it's important to remember that because, well, I'll explain why in this next example, actually. So I'm going to put this away for now. All right, so yeah, and this is kind of similar to 4.1.15. It's not really computing yield rates, but the basic setup of the problem is exactly like this. It's actually 4.1.15 is a mix of this and the example that we just did. Okay, so right, so I have a 20-year 8% bond, semi-annual coupons, face amount 100, and the price is $70.40. First, let's find the yield rate. So remember what, so for here, this yield rate is just the bond yield rate. So yeah, let's just do that. Okay, so for this problem here, the information we have is that it's a 20-year bond. So first of all, click TBM. So there's 40 semi-annual coupons. We're given the face value is 100. So remember, unless otherwise stated, you get your face value back at redemption. So it's not stated anything else. There's no, there's nothing like find the redemption at maturity or any specification at the redemption is anything other than the face value. So we still enter 100 face value, 100 SV. That's the redemption. And we're given that the price is 70.4. So all we do is compute IY. I must have screwed that up somehow, so let me redo that real quick. 40N, 100 face value. I think I forgot to enter face value. It's so easy to make a little error like this when you're focusing on saying the right things in your video presentation. But let's hope I got this one right. No. Try that one more time. 40N, 100. Face value 70.4. I forgot the coupons. That's why we're getting this weird number. So maybe it's good I made this error. If you get really weird answers, you probably forgot to enter something in. I'm not even sure how the calculator came up with the answer I just gave. So yeah, maybe this is a good error, so to speak. Okay, it's an 8% bond, so coupon rate is effective 6-month coupon rate is 4%. So face value is 100. 100 times 0.04 is 4. That's the payment. So compute IY. Now we get the correct answer. This is the effective 6-month interest rate. So we multiply by 2 to get the nominal semi-annual interest rate, yield rate, same thing. And so this is on page 252. And the book just rounds to 11.913%. So, all right. And so I actually didn't do as promised, entering positive for the present value for the previous find the maturity date example. So let's do it here. I mean, we've seen this before, but just to emphasize, 40N, 100 face value, doing everything I just did without the minus for the present value, for payment, compute IY, and you just make the calculator very unhappy. And you don't, again, you do not want to do that in the middle of your exam. You have 3 hours to do 30 problems, 30 convoluted problems, like the most convoluted problems I've ever given you, basically. Don't want to do anything to throw you off. You need the self-confidence. So be very mindful of your minus signs. And I would myself, if I were anyone, I would check that if you enter this as a plus 85,255 present value, but otherwise do everything the same, that you'll get the same error 5 because you've made your calculator unhappy. And again, it makes no sense to enter this as plus. It just, that scenario doesn't make sense. Neither does this, entering it as a plus. Sorry about that. Okay, so let's do B. And B is really what is similar to 4.1.15. So the bond was issued January 15th, 2010, and is bought by the new purchaser for a price of $11.12.25 on January 15th, 2015, just after the last coupon has been paid, or rather the January 15th coupon has been paid. Find the yield rate for the new purchaser. Remember what yield rate means in this context. It means that all the cash in, cash out behaves like they are in an account earning this interest rate. That's what yield rate means. Okay? It's really the same thing as an internal rate of return, which we'll get to in the next chapter. So I'm not really sure why the book even mentions internal rate of return. I think it even mentions it as early as chapter 2, which is really annoying. But anyway, we'll talk about that in the next video, actually. Okay, so yeah, and this is interesting because we're going to have to set this up kind of like we did for this problem here, and it's still 2% here. I don't know why. Anyway, there we go. Right, so we're going to have to set this problem up to basically look like a bond with redemption at maturity that's not the face value. So let's see this problem set up. So first of all, between January 15th, 2010 and January 15th, 2015 is 5 years. So let's draw the timeline for what on earth is going on. And this is a timeline for the purchaser. Okay, so actually this timeline is going to resemble a plain vanilla bond with face value at redemption. It's it's 2 that's not. We'll get to that in a little bit. So so my apologies. We're doing this one where we're finding the yield rate for the new purchaser. So for the new purchaser, we're going from 2015 to 2030. Because it's a 20-year bond, so originally it'd be 2010 to 2030. But so this is 2015 to 2030. So this person gets the $4 coupons and gets 100 back at maturity. So yeah, this is exactly like a 15-year bond with coupons $4 and 100 redemption. Okay, so we don't even care that the redemption is the face value. It is, but so we're going to treat this as if it's a bond, $4 coupons, 100 redemption, and so right. So let's compute the yield rate for this. So we do this like we did in the this example right here, just slightly different. So in particular, what are we going to enter? Well, clear TVM. So I'm going to enter. So 30 is the number of 6-month periods we have. So 30 N. This person purchased the bond for 112,225. So that's the present value. 112,225, and make that minus to make the calculator happy. The coupons are 4, and you get 100 redemption at maturity. So we get 3.347 blah 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 to get the nominal semi-annual rate multiplied by 2. And we get the correct answer. And the book rounds it to 6.696. Right? So unless otherwise stated, find the yield problems, we want semi-annual nominal yield, because that's what everyone likes to work with for bond interest rates. Okay. And I should actually mention, this is kind of funny, I was told that my uncle actually purchased Puerto Rican bonds way back, thinking that it gives you, such an incredible, yield rate and such an incredible bond rate. So you get great coupons, you get your face value back, win-win for everybody. Well, the problem is they defaulted on their bond obligations, so he was kind of, well, shit out of luck. So definitely a very practical, practically important issue if you're ever even going to think about investing in bonds. But anyway, thought that kind of a funny little story. Okay, so let's do 2, and this is a little more interesting, I think. So let's find the yield rate for the original bond holder. So now, from the original bondholder's perspective, we're dealing with 5 years, 2010 to 2015. All right, this person paid $70.40 for the bond. This is their timeline. And now this is exactly like a bond with coupons $4 and redemption $112.225. This is not going to be the face value of a bond necessarily with with an 8. It's not the face value of an 8% bond. 112.225 times 0.04 is definitely not $4. But that's fine. This is still exactly like a bond. $4 coupons, 112.225 at redemption. Okay. So we just enter all this information like we just did before. It's 5 years, so 10 semi-annual payments. We get 112.225 at maturity. Oops, didn't want to enter that as minus, so enter that as a plus. Sorry about that. It's kind of late here, so going on autopilot. Enter this present value. I don't think I entered for payment. Compute IY, and again, multiply by 2 to get a nominal semi-annual interest rate of 18.99984, and the book just rounds it up to 19%. So if you want to look in the book for doing these calculations, just taking the present value of, well, you still need the calculator to do this, but they actually show you what the expressions are for the present values of these two timelines. You should be able to do that very easily, but if you want to see it, it's in the book. Yeah, so all right, hopefully this was informative. And again, I really love this little calculator. There's an article maybe I'll put up on Blackboard where someone was saying that when these calculators came out, they were big and clunky and they cost like $800, but people in finance shelled out that much money because it was just such a time saver to, this was before personal computers were practical. It was just such a time saver and therefore a money saver to be able to do these calculations just so quickly. So just want to emphasize for Exam FM, get start to, make this really become good friends with this calculator, bond with it, no pun intended, get to know it very well. Um, all right, well, anyway, so long, take care, stay safe, and a new video will be coming.